Now in this problem is on a temperature stresses. You can see here. Here what does he say? He say a square steel bar as shown in the figure is initially 1.2 millimeter shorter from the wall. Where is the wall? The wall is present over here. Okay, so the wall is here. See how much is the gap here? The gap he is talking about, this gap. It is how much? 1.2 millimeter shorter than the wall at room temperature. Room temperature is how much? Room temperature is 23 degrees Celsius, he is telling. Okay. Now he wants me to find out what is the maximum temperature increase that can be tolerated without causing any stress in the bar. This means what? The maximum distance the bar can expand when the temperature rises is how much? 1.2 mm. Only that much it can expand. That's what he means to say. Because if it crosses that 1.2 mm, then obviously there will be some compressive stress. Okay. So now what can I write? I can write, first let me write down delta L. Delta L is equal to how much? Delta L is equal to 1.2 millimeter. Okay. Then what else is there? He has given me the length. See, the length is here, L naught. Is it not? This L naught is how much? 2.5 meters. Convert it into millimeters. Okay. L naught is equal to 2.5 meters. That is nothing but 2.5 into 10 cube millimeter. Is it not? Okay. Then what else he has given me? Assume that the steel has a modulus of elasticity of 207 gigapascal. So that he gives me the value of E is equal to 207. Giga is 10 to the power of 9. I will take 10 cube outside and make it megapascal. Okay. Now I have this. And a coefficient of thermal expansion alpha. He gives me the value of alpha as how much? He gives me the value of alpha as 12 into 10 to the power of -6 per degree Celsius. Is it not? This is the information he has given us. Now what he wants? Number A, he wants me to find out temperature, by how much temperature you can rise so that no stress is induced. So now what can I write? I can write delta is equal to alpha into delta T multiplied by L naught. Correct? So this delta is what? Delta is the thing what? Delta L, which is given 1.2 millimeter. So I can write here as 1.2 is equal to alpha is how much? 12 into 10 to the power of -6 multiplied by delta T. Delta T is what? Delta T is equal to T2 minus T1. We don't know T2. That's what we need to find out. Let us see. Okay. Multiplied by delta T multiplied by L naught is how much? L naught is 2.5 multiplied by 10 cube. Okay. So if I do this one, what will be the value of delta T if I bring everything onto the left side and right side when I take all the values, and then I will find out the value of delta T. See, this is the only unknown over here, is it not? You make the calculation, delta T will come out to be how much? Delta T comes out to be how much? 40, delta T comes out to be 40 degrees Celsius. Okay. Delta T is 40 degree Celsius. This is what? This is your part number A. He wants me what he wants. This is A. Okay. Now let's go to B. In B, what he is telling, if the temperature rises to 55 degrees Celsius, calculate the stresses developed in the bar. That's what he is asking. So let's go up now. Now let me change the color. He asks me to find out what in case of B. He wants me, I know what is initial temperature, that is you can call it as a T1 or T0, whatever you want you can call it. That is room temperature was 23 degree Celsius. Okay, so now what he is telling, the temperature is raised to, see here, let's go back to the problem. Let's see, the temperature is if the temperature is if the temperature rises by 30 degrees Celsius, is it not? Initially it was how much? Initially it was 23 degrees Celsius, correct? So now let us go back. So what would be our final temperature? T2 will be is equal to how much? T2 is equal to 23 plus, how much is increasing? Is increasing by another, how much was that? I just forgot. 30, okay. 30 is in case the temperature rises by 30, okay. 30. If you rise it by 30, what will happen? That becomes 53 degree Celsius. Okay, this is your T2. Okay, Shama? Fine. So now what he wants me, your delta T is how much? Your delta T is nothing but your delta T is nothing but 30 degrees Celsius, is it not? Because he is increasing the sorry. I made a mistake. If the temperature rises to 55 degrees Celsius, sorry, 1 minute. Let me just remove this. I think I just didn't see it correctly. Let me see it correctly. Let me go back to the problem and let me check. If the temperature rises by 30 degrees Celsius, okay, find the stress developed in the bar. Okay, so he is raising the temperature by how much? 30 degree Celsius. Yes, what I had written was right. The temperature is rising by 30 degree. Sorry, let me just go to the color. 30 degree Celsius. If you rise by 30 degrees Celsius, what will happen to the final temperature? 23. It becomes 53 degrees Celsius. Or I can simply say delta T is equal to how much? Delta T is equal to 30 degree Celsius. That's what he tells me. Okay. Fine. So now I can simply calculate the length and see whether it is crossing 1.2 or not. If it is crossing 1.2, how much extra it is crossing, I can see. Okay, that is one way. The other way is what? The other way is already there in your problem. I mean, part number one. In part number one, what was delta T? Delta T was 40 degrees Celsius, is it not? When it reached 40 degrees Celsius, then what happened? Then only you had 1.2 millimeter expansion. Now what is the rise in temperature? Now the rise in temperature is only 30. So obviously the expansion will be much lesser than 1.2. So the question of stress arising doesn't arise at all. Okay, because the bar will never go and push the wall. So what can I write now? I can simply say, since delta T is equal to 30 degrees, which is less than 40 degrees, the expansion will be less than 1.2 millimeter, correct? Therefore, no stresses will be, no stresses will be induced. No stresses will be induced. Okay. It's a very simple problem, not really a difficult problem. See, you took each explanation only 5 minutes, not more than that.